Hi everyone, welcome or welcome back to my channel. In today's video, we are going to solve a very interesting problem of binary search. The question is, we have to minimize the maximum distance to gas station. Now let me read out this question. So it says that given a sorted array of size n, which contains the integer positions of n gas stations on the x-axis. Now let me just go through this. Now it says that we have been given an array, okay, this one, which is basically showing the position of gas stations on some x-axis. So suppose these white sticks, these are the gas stations. We have placed them according to the positions given in the array. Okay. Now it says that we have to place k new gas stations on the x-axis. Now additionally, we also have been given k new gas stations. Now in the test cases which I have taken right now, k is 10. Now in this number line only, we have to add 10 more gas stations, okay? But the condition is that the new gas stations which we are going to put over there, they can be placed anywhere on the non-negative side of the x-axis. So negative side is let's say this side. So we're not going to put it on the left hand side. We have to put it on the right hand side only. Then it says that let the distance be the maximum distance between the adjacent gas stations after adding the k new gas stations, and we have to find the minimum value of the distance. Okay, so it says that we have to put it in such a way such that the distances among the gas stations, okay, distances among the gas station, they should be maximum, and we have to minimize that maximum value. Now again, this question is similar to the questions we have done previously, like aggressive cow problem, then split sum problem, and that book allocation problem, where either we have to maximize the minimum value or we have to minimize the maximum value. So the question like these, we always go for binary search and answers approach. Now let's see how we are going to do that. Now let me just remove this. So here we have taken an example, as I said, of example of the first test case I have taken there. Okay. So here I have already arranged the gas stations which have been given already, and we have to place the k more gas stations, right? So do you remember the questions which we solved, which was of the similar kind based on binary search or answers? How we were doing that? First of all, we have to find out that what thing are we targeting right now? What is the thing we have to notice? Is it the number of gas stations, or it's the position of stalls? What we are noticing? So in this case, if you see, we have to notice on the gaps, right? Gap, or you can say the distance between the gas stations, which I'm calling here as gap between two consecutive gas stations. So let us say I'm going to assume something. I'll be assuming that while placing the gas station, the maximum possible gap between any two gas station will be some number, let's say x, and that's maximum possible gap. And by assuming that maximum capacity, I'll be trying to place the gas stations in this number line, and then I'll be checking that if it is possible. Now since question is telling us to minimize that maximum distance, so we'll say that okay, if this capacity is possible, then it's really good. We'll store it inside our answer, but we'll also explore the lesser value because we have to minimize our answer, okay? And if we are noticing that the capacity which we have taken is basically exceeding the number of gas stations, or you can say it's requiring more number of gas stations, so because why we'll discard that case, more number of gas stations, because this is the maximum possible gap. Okay, suppose if our assumption is leading to lesser number of gas stations placed, we can any day decrease this maximum capacity, okay? But if we are getting the number which is leading to exceeding number of gas stations, we can't do anything in that case, okay? So in that case, we are going to discard the left half. It might sound confusing, so we are going to take some example and we'll check that. Now suppose I'll be taking a value, let's say 1, okay? I'm just assuming that the maximum possible gap between any two gas station is going to be 1. So If I try to place a gas station here, let's say and yeah, notice one more thing. The gap between these two gas station is 1. Gap between 2 and 3 is also 1. Gap between 3 and 4, in fact, all the gas station gap is 1. So if the gap between the existing two gas station is already 1, do you think we can place any gas station here? We can't put it, right? We can't put it. But yeah, if there is any number which is lesser than 1, we can put it. So we can say that this number is valid. Okay, we can store it inside our answer. But when we are using one number, means when we are using the maximum gap as 1, we can't put or we can't place any gas station here. Okay. So this is going to be a valid answer. Again, this confusion might comes to a lot of people that why this is the valid answer if it's not able to place any gas stations into this number line. That's because this is the maximum possible gap. Okay, maximum possible gap means if you're considering this as maximum possible gap, you can any day take the lower value than 1. And the lower value will be able to put place all the 10 gas stations here. Okay, so this is the maximum capacity which we are taking here because the question is asking to minimize the maximum distance. So this is going to be a possible answer, but we'll explore the lesser value. So let's go for 0.1. Okay. And yeah, one more thing. It says that the placement of gas stations, it's not necessary that we have to place it only at integer values. We can place it at even decimal values also. It's fine. So let's say now I want to place the gas stations in such a way that maximum possible gap between two consecutive gas station is going to be 0.1. Remember, maximum possible gap. So gaps can be less than 0.1 also, but this is the maximum capacity which I have taken. So right now I'll be checking with 0.1. So this is a very genuine thing which I'm asking. Suppose this is a number line and here this is, let's say, 1. Here I have 2. Okay. Now the distance between them is what? 1. अगर इन दोनों के बीच का डिस्टेंस अगर मान लो 1 है एंड वी वांट टू प्लेस लेट्स से x नंबर ऑफ गैस स्टेशंस बिटवीन देम सच दैट उनके बीच का उन आपस के बीच का जो डिस्टेंस हो वो 0.1 हो, तो फिर कितने नंबर ऑफ गैस स्टेशंस वी कैन पुट हियर? अच्छा, गैस स्टेशंस का नंबर विल डिसाइडेड लेटर ऑन, कितने नंबर ऑफ स्प्लिट्स लगेंगे इस पे. सो वी कैन ऑलवेज यूज दैट मैथमेटिक्स दैट वी कैन से 1 is total basically stretch between 1 and 2, total distance is 1 unit divided by the maximum possible gap which we have taken, that is 0.1. So this we can say this is the number of split or the number of sections which we are making. So this is going to be 10. So if we assume the maximum possible gap is as 0.1, we can make 10 splits between 1 and 2. And if 10 splits, it means how much gas stations we can actually put? 10 minus 1, that's going to be 9. Okay, because like suppose if I'm putting here one gas station, that split is total 2, no? That's why. So now if we try to figure it out, let's say we are going to put, let's say, 9 gas station here. Okay, 9 gas station here, 9 gas station here, then 9 here. And similarly, if we're going to put 9 gas stations in each and every sector, in each and every like part of this number line, then total it's going to be 81 gas stations, which is not even required. That's greater than what is required in the question. So that's not a possible scenario. And if 0.1 is not a possible scenario, it means the gap less than 0.1 will also be not a possible scenario. So we can discard it. Okay, that's why we are using your binary search and answers, because in this question we can figure it out that when we are taking a certain value, then which part of the search space we need to discard, which part of the search space we need to take into the consideration, which is in total basically optimizing our time complexity. So we are going to discard 0.1, and we're also going to discard the values which are less than 0.1. So let's try some values greater than 0.1. I'll be taking 0.5. Okay. Now let's check if it's possible or not if we're giving 0.5 as space. Then I'll put like um, 1 by 0.5, that is 2. Okay. So we will be having 2 split in each section, and 2 split means we can have total 1 gas station in each split. It means that 1 here, 1 here, 1 here. So 1 gas station we can have in each section. So that adds on to total of 9 gas stations. Okay. Now some of you may ask that it's 9 gas station. It's still not meeting the requirement. But let me tell you one thing. This is what we are calculating the maximum gap. Okay. Maximum gap. Even if now we want, we can add that one extra gas station between this or between this, anywhere within this number line. But still the maximum gap for this particular scenario will be 0.5 only. It's not going to change because of that one replacement. So 0.5 is going to be this maximum possible gap, which is a valid answer. And if you want to check some other values also, you can. You'll find out that 0.5 is going to be the minimum maximum distance of the gas station for this test case. So let's try to write its code. Okay, now we'll see that what's going to be the range of our search space. So as it is clearly mentioned here that the index, I mean the position of the gas station cannot be a negative integer. So it has to start from 0. So I'll be taking, wait, first of all it has to be long double. Low is going to be start from 0. And then we'll be having our high. So what can be the maximum value if you're talking about the distance? So we also saw this in the previous question which we solved about the aggressive cows problem. We noticed there that since the search space is about the distance, it's going to be the position of the last stall minus position of the first stall. That's here it's 10 minus 9. That is going to be our end of the search space. So here also we'll be writing that array of n minus 1. I have to declare n also minus array of 0. So here I'll be declaring n. Now here one very important thing is given which I have to tell. Yeah, it says that your answer will be accepted if it is within 1e minus 6 of the true value. So what is 1e6 now? It's basically this value 0.000001. Now why we are doing this, I'll tell you. Because see, it's mentioned here that it's not necessary that we have to place the gas station at an integer value. Okay, we can also place it at some decimal value. Now, if I tell you that if I talk about decimal value, right, between 1.5 and 1.52, infinite number of values exist, right? So, in a classic binary search now, whenever we used to write like while start is less than equals to end or while low is less than equals to high, there will be a time when start is going to be equal to s or it's going to exceed s. So termination can be easy there. But in the cases like this, where the numbers are going to be, infinite number of possibilities are there between two very close numbers itself, there we can use this thing. Okay, 1e minus 6. So what it does now, I'll explain you guys while writing the code. So this is basically our 1e minus 6 value. So instead of writing the way we used to write in the classic binary search, we are going to use here EPS. I'll show you. equals to 1e minus 6. Hmm. Now instead of writing while low is less than equals to high, I'm going to write while high minus low is greater than EPS. Now what it says that suppose any two number which are too much close to each other such that their difference is going to be this number, then we can terminate there. Because if the difference between two number is this, that is 0.000001, it means both of them are too close to each other, so there we can terminate it. So that's why we are going to use here EPS. Okay, so then we are going to continue with our natural flow of binary search. Long double mid is equals to low plus high minus low by 2. Then again the same way which the way we were doing there. Now this mid is going to be our assumption, right? Which we were doing here. We were assuming certain values, and then how we were checking that logic we are going to write in a separate function. And what we were telling that if the assumption is true, we are going to check to with a smaller value. We'll try to shrink our search space with a lower value because we have to minimize the maximum value, right? So if this functions comes out to be true, I'll be now here one more thing. What we used to do in the previous questions, we were doing high is equal to mid minus 1. But here we won't do that. Why? Because the possibilities of the answer could also be any decimal value. So if we do minus 1, it's going to skip a lot of basically a variety of decimal numbers. So we won't be doing here minus 1, we'll be doing here high is equals to mid. And else part also we won't be doing s equals to mid plus 1, or you can say low is equal to mid plus 1, but we'll simply do low is equals to mid. Because the moment we do plus 1 minus 1, we are going to skip a wide variety of possible decimal values which possibly could be the answer. That's why. So here we'll be returning our high. Okay, because we have to basically we were looking for the maximum value, and then I'll be writing this function. So I'll keep its name as it's isPossible. And parameters, I'll be first putting this array, then mid and that k. Mm, array. Okay, now let's write this function. Bool is possible. I'll be copy pasting this. Int mid and then int k. Okay. Now how we were doing there? We were basically initializing with a zero count. Okay, count means we were basically counting this number of gas stations which we can put on this number line, right? So that I'm denoting it with count, that is 0 initially. Then what we were doing, we were traversing across this array, and but we were first checking. Now in this test case which I took here, basically it was a coincidence that all the numbers were having uniform gaps of 1 unit, but that might not be the case in other test cases also, right? So first of all we'll traverse and we'll be keep on finding the gap between two consecutive gas stations. Okay, so for int I equals to 0, I less than array dot size I plus plus, and yeah, we'll be doing this minus 1. We won't be considering the last element while doing this because we have to see for the gaps, right? So there's no need to reach this element. Now I'll see gap कितना है दो के बीच में, right? So long double gap is equals to array of I plus 1 and array of I. Okay. Now this is what okay, we were using here I plus 1, now that's why we have put here minus 1. My bad. Okay. Now we have calculated the gap here. Now what we were doing, we got the gap that is 1 in this example. Now we were dividing it by our assumed value, right? That's 0.5, or sometime we took 0.1. We will divide it by it and we'll do minus 1. And then we are going to check that how many gas stations we can put, and we'll be adding them in total in our count variable. Let me show you how. Okay, so we got the gap. Now we'll see how many gas stations are required there, or you can say it can be put there. So in required equals to, because gas stations is going to be an integer only, so, and here I'm going to take a ceil value, gap by mid, and we'll do here minus 1, because if we won't do there minus 1, it will just tell us the number of splits, it won't tell us the number of gas stations. Then we'll do here count plus equals to required. So what it's doing, we have initialized a global variable count. We're iterating towards the each gap, and we are checking the possibilities how many gas stations can be put inside that gap. We are doing that for all the gaps here, and we are accumulating all the number of gas stations, and then we got our count variable at the end of the loop, right? And here we were checking that if the total number of gas stations which can be put here, if that's less than equals to k, it means that is a possible answer, or else that's not, you have to increase your number, right? So we'll check here that basically we'll simply return it, count is less than equals to k. Okay, wait. Okay guys, so now I understood why it's not working, because we were using long double data type here to calculate the mid, right? But when I was passing it here, I was using int. Let me change it to long double. Now it will work. Okay, wait. Yeah. Now talking about its space and time complexity. So for space, we're not using as such any other extra space for it. So that's going to be constant space. But for time, we are iterating here first of all n time. So that's big O of n into one more thing. We are using the main binary search. So that's going to be bigger of that n into log of the size of the search space. That's this one. So if this is, let's say, d, then we can say that's going to be big of n into log d. So this was all about it. Thank you for watching.